When troubleshooting a bank of 3 transformers where the cutout blows instantly, systematic testing is crucial. Here's a step-by-step approach to isolate the faulty transformer. Firstly, and most importantly, always prioritize safety. Disconnect all power sources from the transformer bank before beginning any testing procedures. This includes both the primary and secondary sides. Wear appropriate personal protective equipment, including safety glasses, insulated gloves, and arc-rated clothing. Ensure the work area is clear and safe. Secondly, perform a thorough visual inspection of each transformer. Look for any signs of physical damage, such as bulges, cracks, oil leaks, or burnt components. Check the bushings for any signs of arcing or contamination. Document any visible issues you find. Thirdly, conduct megger testing on each transformer individually. To do this properly, disconnect the primary and secondary connections of each transformer from the bank. This isolation prevents inaccurate readings due to parallel paths. Ensure your megger is calibrated and functioning correctly. Ground the megger properly to a reliable earth ground. Perform insulation resistance tests between the primary and secondary windings of each transformer. Also, test the insulation resistance between each winding, primary and secondary, and ground. Record all readings carefully. Compare the megger readings for each transformer. A significantly lower reading on one transformer compared to the others indicates a potential internal fault, such as insulation breakdown. If all transformers show similar readings, proceed to the next step. Fourthly, consider performing an insulation resistance ratio test. Connect the megger to the primary and secondary terminals of each transformer, ensuring they remain disconnected from the bank. Measure the insulation resistance of each transformer at a high voltage, typically 1000 volts or 5000 volts, depending on the transformer's voltage rating. Then, measure the insulation resistance at a low voltage, for example 50 volts. Calculate the IRR by dividing the insulation resistance at the high voltage by the insulation resistance at the low voltage. A significantly low IRR for one transformer compared to the others can indicate winding insulation damage that may not be apparent from a single megger reading. Fifthly, perform a polarity test to verify the correct winding polarity of each transformer. Temporarily connect the secondary windings of all 3 transformers in parallel. Apply a low voltage, such as 12 volts, across the secondary windings of one transformer. Using a voltmeter, measure the voltage across the secondary windings of the other 2 transformers. The voltage should be equal in magnitude and opposite in polarity. If one transformer shows a different polarity, it indicates a potential winding fault or incorrect connection. Sixthly, conduct a turns ratio test to check for shorted or open windings. Disconnect the secondary windings and connect the primary windings of all 3 transformers in parallel. Apply a low voltage, such as 12 volts, across the primary windings. Using a voltmeter, measure the voltage across the secondary windings of each transformer. Calculate the turns ratio for each transformer by dividing the primary voltage by the secondary voltage. The turns ratio should be approximately equal for all 3 transformers. A significantly different turns ratio for one transformer indicates a potential winding fault. Seventhly, if the megger, polarity, and turns ratio tests do not reveal any issues, consider checking the transformer connections and the components in the bank. Inspect the connections for tightness and corrosion. Check the fuses, circuit breakers, and surge arresters for proper operation. Use a thermal imager to check for hotspots on the transformers and connections. Excessive heat can indicate a problem. Eighthly, analyze your megger test results carefully. The insulation resistance value depends on the transformer's voltage rating, size, and age. Consult the manufacturer's specifications or industry standards for acceptable values. Pay close attention to any trends or sudden changes in insulation resistance over time. Ninthly, remember that a megger test applies a DC voltage to the transformer windings, which can be affected by moisture or contamination. If the insulation resistance is low, try drying out the transformer by heating it or using a vacuum pump. Retest the insulation resistance after drying. Tenthly, when performing the polarity test, ensure that the voltmeter is connected correctly and that the polarity is consistent. A digital voltmeter with a polarity indicator is helpful. Be careful when working with live circuits, even at low voltages. 11thly, when performing the turns ratio test, use a voltmeter with sufficient accuracy to measure the low voltages involved. A digital voltmeter with at least 3.5 digits is recommended. Consider using a dedicated turns ratio tester for more accurate results. 12thly, if all tests indicate that the transformers are healthy, the problem may lie elsewhere in the system. Check the upstream and downstream connections, cables, and equipment. Look for any signs of ground faults, short circuits, or overloads. Use an oscilloscope to analyze the voltage and current waveforms and identify any abnormalities. 13thly, if you are unsure about the test results or the troubleshooting process, consult with a qualified electrician or transformer specialist. Transformers are complex devices, and improper testing or repair can lead to serious damage or injury. 14thly, document all test results and observations carefully. This information will be helpful for future troubleshooting and maintenance. Keep a log of all repairs and replacements performed on the transformer bank. 15thly, before putting the transformer bank back into service, ensure that all connections are tight and secure. Verify that the voltage and current are balanced across all three phases. Monitor the transformer bank for any signs of overheating, vibration, or unusual noise. 16thly, understand that megger readings can be affected by temperature and humidity. Record the temperature and humidity when performing megger tests and correct the readings accordingly. Consult industry standards for temperature correction factors. 17thly, when performing the polarity test, use a low voltage source that is isolated from ground. This will prevent ground loops and ensure accurate readings. 18thly, when performing the turns ratio test, ensure that the applied voltage is within the transformer's rated voltage range. Applying excessive voltage can damage the transformer windings. 19thly, if you suspect a winding fault but cannot confirm it with the standard tests, consider performing a double test. A double test is an advanced diagnostic test that can detect subtle insulation defects. 20thly, if you find a faulty transformer, replace it with a transformer of the same voltage rating, kVA rating, and impedance. Using a transformer with different characteristics can cause imbalances in the system and lead to further problems. 21st, consider using a transformer oil analysis to assess the condition of the transformer oil. Oil analysis can detect contaminants, moisture, and other degradation products that can affect the transformer's performance. 22nd, regularly inspect and maintain the transformer bank to prevent future problems. Clean the bushings, tighten the connections, and check the oil level. Schedule periodic megger tests and oil analysis to monitor the transformer's condition. 23rd, be aware of the potential hazards associated with working with transformers. Transformers can store large amounts of energy, even when they are de-energized. Always discharge the transformer windings before working on them. 24th, remember that transformer troubleshooting requires a combination of technical knowledge, practical skills, and attention to detail. Take your time, follow the proper procedures, and always prioritize safety. 25th, when interpreting megger test results, consider the polarization index pi and the dielectric absorption ratio dar. The pi is the ratio of the insulation resistance at 10 minutes to the insulation resistance at 1 minute. The DAR is the ratio of the insulation resistance at 1 minute to the insulation resistance at 30 seconds. These ratios can provide additional information about the condition of the insulation. A low PI or DAR may indicate contamination or moisture in the insulation. 26. If the transformer has an on-load tap changer, exercise the tap changer through its full range of positions. Check for smooth operation and proper voltage regulation. Inspect the tap changer contacts for wear or damage. 27th. If the transformer has a sudden pressure relay, SPR, check the relay for proper operation. The SPR is designed to detect sudden pressure increases inside the transformer, which can indicate a fault. 28th, when replacing a transformer, ensure that the new transformer is properly grounded. A good ground connection is essential for safety and for proper operation of the transformer. 29th, consider using a transformer monitoring system to continuously monitor the transformer's condition. These systems can provide early warning of potential problems and help prevent failures. 30th, be familiar with the relevant industry standards and regulations for transformer testing and maintenance. These standards provide guidance on proper procedures and safety precautions. 31st, when troubleshooting a transformer bank, it is helpful to have a schematic diagram of the system. The schematic diagram will show the connections between the transformers and other components, which can help you identify potential problems. 32nd, if the cutout blows instantly, it suggests a significant fault current. This could be a short circuit within the transformer itself, or a fault on the load side of the transformer. The megger test should help identify a winding to ground or winding to winding fault within the transformer. However, if the megger test doesn't reveal a fault, the problem might be intermittent or only occur under voltage. 33rd, if the megger test shows a low resistance reading on one transformer, it is likely the cause of the problem. However, before condemning the transformer, it is important to rule out other possible causes, such as a faulty connection or a damaged cable. 34th, when performing a megger test, it is important to use the correct voltage level. Using too high of a voltage can damage the transformer insulation, while using too low of a voltage may not reveal a fault. Consult the transformer manufacturer's specifications for the recommended test voltage. 35th, if you suspect a problem with the transformer oil, take a sample and have it analyzed by a qualified laboratory. The oil analysis can reveal the presence of contaminants, moisture, and other degradation products that can affect the transformer's performance. 36th, if the transformer is equipped with a gas accumulator, check the gas for the presence of combustible gases. The presence of combustible gases indicates a fault within the transformer. 37th, when replacing a transformer, ensure that the replacement transformer is compatible with the existing system. This includes the voltage rating, kVA rating, impedance, and connection configuration. 38th, if the transformer is connected to a sensitive load, consider using a harmonic filter to reduce harmonic distortion. Harmonic distortion can cause overheating and other problems in the transformer. 39th, regularly inspect the transformer bushings for cracks, chips, and other damage. Damaged bushings can lead to insulation failure and transformer failure. 40th, when working on transformers, always follow lockout-tagout procedures to prevent accidental energization. Accidental energization can result in serious injury or death. 41st, remember that transformer troubleshooting is a process of elimination. Start with the simplest tests and gradually move to more complex tests as needed. 42nd, if you are unsure about any aspect of transformer troubleshooting, consult with a qualified electrician or transformer specialist.